Welcome to the second in this series of 3 videos in which I'm building a replica of Brian May's legendary Deacy Amplifier. In this video I'm going to unbox and assemble this electronics kit for the Deacy Amplifier board, which is made by Knight Audio Technologies. I'll also take the opportunity to talk about the Deacy board and some of its components. Throughout the video I'm going to make reference to the comprehensive 22-page fully illustrated instructions for assembly and test compiled by Nigel Knight to accompany this kit. You can download a copy for free in PDF format from the CAT website www.deacyamp.com. As you watch me unbox all the components, I'll read out the introductory paragraph from Nigel's assembly instructions. Congratulations on buying this Deacy Amplifier board kit. It has been many years in the making. It has everything you need to build a highly accurate Deacy Amp board to the same specification as the one residing in Brian's legendary Deacy Amp. Even the transformers are exactly the same specification as Brian's. We have tried our best to make this amplifier relatively easy to build, so if you can solder, you can build this kit. Items that require specialist tools to assemble have been pre-made and assembled, so you won't need bespoke riveting presses for the heatsink or hot air guns to shrink the sleeving on the battery leads. It's all been done for you. And finally, we have even included the very rare and exceedingly hard to find vintage TO1 large can transistors that have all been individually tested and matched to ensure the amplifier performs perfectly. So I've already taken out the heatsink assembly and shown you that. What I'm holding up there is a bias trimmer pot assembly. Also holding in my hand I've got the 1/4-inch jack socket, obviously for the speaker cabinet, and the 2-terminal speaker connection strip also for the speaker cabinet. The rest of these small miscellaneous items consist of a 470R test resistor, some sleeving for the transistor legs, and some VERO pins to solder onto the printed circuit board. And this is clearly a pack of resistors. There's 14 in total, not including the 470R test resistor I showed you earlier. Next up are these set of 4 vintage TO1 germanium transistors. There's 2 AC128 transistors, an AC125 and an AC126. Next up is this bag of capacitors. There's 7 electrolytic capacitors and 1 mylar film capacitor, which is a green block. Next up is the printed circuit board itself. This has the same track layout as the original board, but it has the tracks gold-plated rather than tinned. Nigel says that the problem with vintage FR2 boards is that the tracks can easily lift with too much heat application, so rather than risk lifting tracks during the tinning process, they used gold-plated instead. Nigel says also that if you're intent on achieving the true vintage feel of the original, you can tin the tracks with solder. Finally then, there's some miscellaneous leads which have been all cut to the correct size. There's a battery lead assembly with blue connectors for the PP9 battery, some screened cable for the jack socket, 2-core speaker cable, which has the grey sleeve, copper and tinned, and internal power connecting wires, yellow and grey. Now let's unbox the Deacy transformer set. This consists of 2 transformers, an interstage transformer designated T1, and an output transformer designated T2. As you watch me unbox and take a look at these transformers, I'll read out the information that Nigel's included in his assembly instructions. There has been a lot of speculation and discussion about the transformers fitted to Brian's original Deacy amp, and it is considered that the exact winding ratios and resistances and generally the windings of the transformers do play a significant part in shaping the tone of the original Deacy amp. We know from research carried out by Manuel Angelini, who runs the Doxy World website, and he's from France, that the board comes from a Supersonic brand radio. And these were made in the 1960s in Bulawayo in Rhodesia, which is now Zimbabwe. There are original circuit diagrams available on the internet showing the circuit of the supersonic amplifier, and these clearly show the output transformer being in an auto transformer configuration. However, in Brian's original Deacy amplifier, the output transformer is not configured as an auto transformer. It has isolated windings. So whether this is by accident or part of an earlier trial, that's not really known. Let's take a brief look at the Deacy amplifier circuit. This is a mid-20th century push-pull audio circuit which uses 4 germanium PNP transistors. an AC125 in the audio frequency amplifier stage, an AC126 in the driver stage, and two AC128 transistors in the output stage. As I said earlier, it also features two transformers, one driver and one output, and is similar to several contemporary designs in the Mullard reference manual of transistor circuits on pages 171 and 172, which I'm showing you now in the shot. These Mullard reference manuals of transistor circuits are in paperback form. This is the second edition, dated 1961, and you can pick these up, in the UK at least, on eBay for less than £10. I do recommend trying to find one of these books if you are at all interested in the history of transistor electronics. Now let's take a look at some of the tools and equipment that I'll be using to assemble this circuit board, some of which are optional, some of which are essential. Let's take a look first at this Weller WD1 temperature-controlled soldering unit. These are quite expensive and used by a lot of professional electronics assemblers. It's difficult to justify that kind of expense for occasional hobby use. I was able to pick this one up on UK eBay, it was in good condition, and I made a substantial saving. I prefer to use a high lead content solder which has a lower melting point. This one is a 0.7mm diameter, has 5 cores, and has a non-corrosive flux. I'll test all the passive components such as the resistors and capacitors using this Peak Atlas LCR45 inductance, capacitance, resistance and impedance meter. I'm going to use the Peak Atlas DCA55 semiconductor component analyzer to check the HFE gains, the leakage currents, and base emitter voltage of the 4 transistors. Right, let's start by very quickly unbagging and testing all these resistors. So I'll just test them and place them onto the chart here in the order that they come out, and I'll read them out in the order that they are on the chart. R1 is 12 kilo ohm, R2 is 47 kilo ohms, R3 2.2 kilo ohm, R4 3.9 kilo ohm, R5 330 ohms, R6 2.2 kilo ohms, R7 1 kilo ohm, R8 10 kilo ohm, R9 68 kilo ohm, R10 560 ohms, R11 and R12 are 4.7 kilo ohm, R13 is 4.7 ohms, R14 is 120 ohms, and the test resistor is 470 ohms. In the next phases of the video, I will load the circuit board with all the various passive components, starting here with the resistors, then I'll solder each set of passive components before moving on to the next. I'm now following page 5 of Nigel's instruction sheet, and I'll read out some of the information there if you're a novice at assembling electronic components like I am. So I've started with R1. This is a 12 kilo ohm resistor, and it sits midway up the board on the left-hand side. The spacing between the mounting holes is approximately 16mm for most of the resistors, so that's the spacing I need to pre-bend the resistor legs to. I'm locating each resistor and carefully bending the legs downwards, both in the same direction, so there's a nice uniform radius at each bend, approximately 4mm from each end of the resistor body. Nigel uses his thumbnail to bend the leads over, and I've just used a set of small pliers. The resistors should all now simply drop into the position, with the leads protruding through the holes to the other side. Nigel advises that it's generally accepted practice to load the bulk of the components so that their values can be read from left to right or from the bottom to the top. So in the case of the resistors, that places the gold tolerance band either on the right or at the top. You can't apply this rule of thumb for all the components because some of them, such as the electrolytic capacitors, are polarity conscious, so you must install those as required by the circuit rather than board aesthetics. So that's all the resistors loaded onto the board. Let's review what the board looks like at this stage. Comparing the board to the picture and the instructions, it looks correct to me. I'm satisfied with that. So let's now move on to soldering up the resistors. Since the soldering operations are very repetitive, in the rest of the video I'll heavily edit these to shorten the sequences and or speed them up. Okay, so that's all the resistors loaded onto the board and all the resistor legs soldered. So let's now move on to the next phase, which is to install and solder the electrolytic capacitors. As you watch me unpack, test and load these capacitors onto the circuit board, I'll read out a paraphrased version of the information from Nigel's installation instructions. The Deacy Amp circuit board uses axial format capacitors on all the electrolytics. Axials are pretty standard in the 1960s because radials back then were too large and bulky and generally only used for larger filter types. The one exception is the 220 nanofarad mylar film capacitor that forms half of the Zobel network across the output transformer primary. The capacitors need to be installed starting with the smallest, the 2.2 microfarad units. On these axial capacitors, the polarity is identified by two methods. Firstly, there's a ring indent around the outside at one end, which also has insulating material around the point that the lead enters the can. This is the positive end of the capacitor. On the case, there's also a band of printed arrows with minus signs in them pointing to the opposite end, the negative end. Okay, so that's all the capacitors now loaded onto the circuit board. Let's have a quick look and review that before we move on to soldering the capacitor legs. The lead-based solder I'm using here has a melting point between 183 and 188 degrees Celsius, so a good temperature to set the soldering iron at, if you do some research, is 316 to 343 degrees Celsius, so I just picked 340 degrees Celsius, and as you can see, that seems to work well with this solder. That's all the capacitors installed and soldered up, so let's now move on to installing and soldering the bias trim pot assembly. The bias trim potentiometer assembly is a 100 ohm variable resistor that can be used to adjust the current draw of the amplifier. And I'll show this process in a later sequence where we attach the 470R test resistor and adjust the screw on the test pot assembly to give a current draw between 5 and 6 milliamps. These trim pot assemblies have been custom made to fit into the same footprint as the original vintage items. Now, we talked about the transformers earlier, so I won't cover that again. At this stage, I'm just going to load the transformers into the board. Nigel notes that it's almost impossible to get the wrong transformer in the wrong position. It is possible to wrongly orientate the output transformer, so we just need to be really careful with that as we load them up. Carefully lining up the legs with the holes in the board and gently wiggling the transformer into place. As before, we'll just illustrate a little bit of that soldering process, speed it up for you, and then we'll review what we've done so far. Okay, so with the resistors, the electrolytic capacitors, the mylar film capacitor, and the two transformers and the bias trim pot assembly loaded on and soldered, the board should now look like this. Next up, we're going to mount the heatsink assembly. So to do that, we'll locate the two tab legs and gently ease them into the output transformer tab holes. The main bodies of the transistor clips should be uppermost and the eyelets underneath. The heatsink assembly should push all the way into the board and sit flat and level on top. If it does, we'll then bend over the heatsink solder tabs outwards, trim the excess off flush with the board, and then solder them on. Just to notice there, as I was handling the assembled board, I've managed to bend over the legs of the green mylar film capacitor, so just be careful with that, because that capacitor is quite fragile. I'll sort that out later. Okay, so that's the legs of the heatsink bent over, trimmed flush with the edges of the board, and soldered to the PCB track. Well, that brings us to the most daunting part of the assembly, certainly as far as I'm concerned, because my soldering isn't as precise as perhaps it could be, and that is the 4 vintage germanium transistors. The AC125 and AC126 variants are getting quite hard to find. If you can find these on eBay with the correct HFE gains and acceptable leakage currents, you could end up paying between £5 and £10. Just to summarise the tests I'm doing here for you, the AC125 transistor has an HFE gain approximately 150, the AC126 approximately 300, and the two AC128s have HFE gains of approximately 100. Just for reference, I did check with Nigel Knight as to whether he was happy with me testing and showing you the values of all these components on camera, and he's given me permission to do that. Now I'm carefully inserting the two AC128 transistors into those copper heatsinks, and then putting on the pre-cut lengths of insulated sleeving. Although I've tested them with the Peak Atlas DCA55 semiconductor component analyzer, Nigel's already identified the collector with a red dot painted on the can. As you can see here, the two AC128 transistors are oriented in opposite directions. So it just remains to bend the three legs, the collector, base and emitter of each of the two AC128 transistors, and locate them into their holes on the PCB. Let's have a quick review of that installation. That looks okay to me. So we'll move on now, and I'll solder each of the collector, base and emitter legs separately in order to let the heat disperse. So I'm showing you each of these soldering operations in real time. I'm trying really hard here to not let the heat of the soldering iron contact the pad for more than about 3 seconds. Okay, so that seems to have gone well. Let's take a look at what the board looks like now. Quite happy with those solder joints. Next up then is preparing, loading and soldering the AC126 transistor. Once more, I'm just being very careful to ensure I don't contact the solder pad for more than about 3 seconds so as not to overheat and damage these delicate vintage transistors. And finally, it's a repeat of the previous process with the AC125 transistor. Again, just double check that it's oriented in the correct way, the collector, base and emitter in the right holes. Load it up and we'll solder it on, taking the same care we did as previously. To finish up here then, we'll just trim the excess wire off those legs and inspect the board as it stands. That's all 4 transistors installed. That AC125 is leaning at a slight angle, could have done better there, but I'm satisfied with that. So with all the main components now installed onto the board, let's take the opportunity to review the appearance of the board compared to Nigel's pictures. We've been reviewing as we went along, so I shouldn't expect any issues. So let's move along now to installing this power supply link wire. Nigel has supplied this piece of wire pre-cut and pre-tinned, so there's nothing special to do here other than to bend the ends of the wire over into 2 small loops to allow them to sit neatly over the stumps. Okay, we're getting close to the end now, so I'm just quickly installing these 6 VERO pins to allow the external wires to be soldered on. And finally, let's just solder those VERO pins in place. And then we'll quickly go through the soldering of the external wires. This is the input jack socket tip and sleeve. Unfortunately, I've managed to mess up the piece of grey single-core screen cable that Nigel provided, so I've had to supply my own piece of 2-core cable here. Lastly then, we'll just solder the other ends of the speaker cable onto the speaker solder terminals itself. And finally, we'll attach and solder on the 470R test resistor. To set the correct output of the amplifier, you attach a multimeter, set it to measure milliamps, place the probes in line with the 470R test resistor, and adjust the trim pot to give an output of between 5 and 6 milliamps. So I'm quite content with that. So to test the amplifier, I'm going to connect it up to my Guyton RS Transporter guitar through a Cat Ringmaster treble booster that's been hand-built by Nigel, and it's a clone of the Dallas Rangemaster circuit. We've connected it up to a new ever-ready silver 9V PP9 battery. Then we'll give it a try. We'll just play a few individual notes so that you can hear the clarity and quality of the output. Okay, so we've got some interference there. Presumably the circuit isn't very well grounded. If I pick it up and handle it, it's grounding through me. Okay, that's the end of the video. So thank you very much for watching. Please consider subscribing to my channel and check out my website dsgb.net.